Hi everyone, this is your math guru. Today we're going to solve a few examples applying the chain rule to our differentiation. Please don't forget to subscribe below for more easy to understand math concepts and more examples for your chosen topic. In my first example, I have find dy dx when a y equals in bracket x squared minus 1 all to the power of 3 over 2. Let me call that my equation 1. Let my u equals x squared minus 1. Let me call that my equation 2. That's my inner function. Du dx is equal to 2x. If I substitute equation 2 into 1, I'm going to have y equals u to the power of 3 over 2. And if I differentiate y with respect to u, I'm going to have 3 over 2 u to the power of 1 over 2. Now I have two differentiations that I'm going to use in my chain rule, which states that the y dx equals the y du times du dx. Substituting, I'm going to have the y du is 3 over 2 u to the power of 1 over 2 times du dx, which is my 2x. If I substitute back the value of u, I'm going to have 3 over 2. My u is x squared from equation 2 minus 1 times 2x. And if I simplify, my final answer, the y dx, is going to be 3x in bracket x squared minus 1. I missed out my half here. It's the power of half. Let's look at another example. In the second example, I have y equals x squared minus x minus 2 all to the power of 4. I'm going to call this my equation 1. Let u equals x squared minus x minus 2, which is my inner function. I'm going to call that equation 2. And if I differentiate u with respect to x, I'm going to have du dx equals 2x minus 1. I'm going to be using that for my chain rule. Then substituting back u into my original equation, I'm going to have y equals to u to the power of 4. If I differentiate y with respect to u, I'm going to have 4u3. My chain rule states that the y dx equals the y du times du dx. I'm putting the values I have earlier. I'm going to have the y dx equals the y du is 4u3 to the power of 3 times du dx. Because it's an expression, I'm going to put it in a bracket, minus 1. And if I substitute back the value of u, I'm going to have 4 in bracket. My u from equation 2 is x squared minus x minus 2 times my 2x minus 1. Therefore, my dy dx is going to be 4 in bracket 2x minus 1 and x squared minus x minus 2. Let's go ahead to another example. Before I go ahead, I'm going to include, I omitted my power of 3 here, and I'm also going to add that to my answer, the power of 3. In this example, I have find the y dx when y equals 1 over 4x squared plus 4. I'm going to move my expression at the bottom or my denominator to the top, which gives me y equals 4x squared plus 4 all to the power of minus 1. That is my equation 1. Then I have let u equals my inner function, which is 4x squared plus 4. That is my equation 2. If I differentiate 2 with respect to x, I'm going to have 8x. I'm going to be using that when I finally applied my chain rule. If I substitute equation 2 into 1, That means replacing that expression with u, I'm going to have y equals u to the power of minus 1. If I differentiate y with respect to u, I'm going to have minus 1 u to the power of minus 2. My chain rule states that the y dx equals the y du times du dx. And putting back my equation, I'm going to have the y du, which I have as minus 1 u to the power of minus 2 times du dx, which is 8x. Substituting the value of u, I'm going to have the y dx equals minus in bracket, my u is 4x squared plus 4 times 8x. If I simplify and tidy up my answer, I'm going to have dy dx equals, I have my exponent. Please don't forget to put your exponent. That's minus 2. Then I'm going to have minus 8x in bracket 4x squared plus 4 to the power of minus 2. And if I want to leave it as a positive exponent, I'm going to have dy dx equals minus 8x all over in bracket 4x squared plus 4 to the power of 2. In our last example, we have y equals, in bracket, square root of x minus 1 all to the power of 4. Let our u equals to our inner function, which is my root x minus 1. This is my equation 2. This is my equation 1. If I differentiate my second equation, before I do that, I'm going to change my root of x to a rational exponent, which is half minus 1. Therefore, my du dx is going to be 1 over 2 x to the power of minus half. Substituting equation 2 into 1, I'm going to have y equals u to the power of 4. And if I differentiate y with respect to u, I'm going to have 4u to the power of 3. My chain rule states that the y dx equals the y du times du dx. Substituting back, I'm going to have the y du, which is my 4u to the power of 3, times my du dx, which is half x to the power of minus half. If I substitute back my u, I'm going to have 4 in bracket. My u from equation 2 is root of x minus 1 all to the power of 3 times 1 over 2. I can make this a positive exponent and also change my rational exponent. So that's going to be 1 over 2 at the bottom. My denominator is going to be root of x. If I tidy up my equation by simplifying, I'm going to have my dx equals 2 in bracket root of x minus 1 all to the power of 3 all divided by root of x. Thanks for watching. Bye.